Hello everyone, how are you doing? I hope you're doing great. I have a little bit of a new setup here for the streaming, that's why it took me a little longer. Sorry about that, I will explain it in a second. Let's first do a couple quick tests. Let me know if you can hear me well and see me well. We will take a look at my desktop, so let me know if you can see this. Now you should be able to see the text, right? Yes. And me in the corner, if that looks sharp and crisp, if the font size is okay like this, or probably I should increase this a little bit. Let's try like this. Let me know if that's better. And okay. Let me get the chat again here. Already 3 viewers. Hey there, how are you? Let me just check myself if the preview player works. Okay, that looks good. So I will actually make this here a bit smaller. Give me a sec. And yeah, let's also do the classical delay test. So I don't know if I set up this stream to use the setting for, probably I can't change that now, for low delay. So let's just try how it is. So I'm going to count to 3, and on 3 I will clap my hands. And when you see and hear me do that, just spam something in the chat, whatever you want. And we'll see, I actually just spam clap in the hand so I can distinguish it from the normal kind of spamming. So we see how long the delay is between me saying stuff live on this earth and you receiving it on the other end of earth. Okay, ready? 1, 2, 3. Right. 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16. Okay, 16 to 17 seconds, I would say. That's a bit longer than usually, but not too bad. I think we can work with that. Alright, cool. Thanks for participating. Already so many people, holy shit, okay. I was planning to wait a little bit before I explain what we'll be doing today and the next days until there's more people, but I think we're already enough. You're all on time. So, whoops. So let me tell you what the situation is. So I have some free time, which I can mostly dedicate to Citybound, and I decided why not to go hardcore and do as many live streams as I can for as long as I can. Today is the first day where I'm going to do that. We will just work on whatever needs to be done for Citybound. So right now that's still the zoning prototype, and I wrote some blog posts about that. I will explain in a little more detail what we're going to do exactly today in a couple minutes. So let's first talk about some organizational things. I really plan to stream for as long as I can. I will obviously need to take breaks to eat something. But apart from that, I will just do mostly coding live streams first until I get too tired to concentrate on that, and then I will switch maybe to the more classical patrons calling kind of live stream where I open a Google Hangouts and you people can call in and we have more kind of a discussion. If you have any ideas or wishes for what we could do on stream or how we could interact, let me know at any point in time. If probably while I'm programming, I won't be checking the chat that much. So if you want me to see something, write it a couple times until I see it, and write it in the times when I'm taking a break. So I think just to get a bit warmed up, I will do a good old quick chat Q&A session. Just if you have any questions that you've been wondering about in the past couple days, go ahead and we'll do a couple minutes of that. And then I will introduce what we are actually going to work on today. All right? So, one cool thing, by the way, I mean, I will always try to show the chat on screen, but YouTube actually now has this really cool new feature where the live chat will be replayed for people who watch the live stream later, so you will be able to see our interaction in real time. Okay. Maybe while you're thinking of questions, one quick explanation why it took me a little longer to set up the stream this time. I was hoping to get a really cool setup going where I would have my DSLR camera over there and actually use that as a webcam. It's possible, and I got it set up. The problem is that I don't have a long enough USB cable to transmit the video like that. And over Wi-Fi, it's a bit too laggy. Like it's the frame rate is too low, and it's also has a delay compared to the audio, which you're going to hear from me. So let's see. Maybe tomorrow I'll find the time and quickly buy a long USB cable, because I think it will look slightly higher production quality than the built-in webcam of my MacBook here. Yeah, later, I don't know how it will be. I always really like to listen to some music while coding. I found some music from Twitch TV actually on Spotify that is apparently royalty free, where I won't get into copyright problems. And when we do that, first of all, let me know if that's something that you'd appreciate, or if it annoys you because you want to listen to your own music in the background. But if we do that, I'll put on headphones, and I should have set it up that so you can actually also hear my system sound. We can actually try that. How can we try that? By pressing... I'll go into the editor here and press a weird combination of buttons, and you should hear that in the stream as well. Let's see, I tried, I think. No. Okay, I'm just doing stuff that actually does something, and now I'm afraid. Whatever. We'll see later. And also when we're doing the... Also when we are doing the Hangout calls, then we should really check that it works. Because I'm not using this quick setup, which is called Hangouts on Air, where I'm basically streaming using the Google Hangouts client. I'm streaming, as you can see now, with the open source broadcasting software here. Whoops. And when we have calls, we should really make sure that you can hear the audio of the other people calling, obviously. But I think it should work. I tried it. And I think that's all the technical stuff that we need to talk about. So Obi Simmons asked me did you get any grants from university? I think I mentioned that that's something that might be an option in the future. No, not yet. I still have to talk to some more people there, basically. I have some people who are interested in Citybound in general. I want to make an official project out of that. I was kind of putting that off because it's quite a big commitment for one semester. And I was afraid that during this time I would basically be forced to only implement whatever thing that I promised them to implement in Citybound. So I don't know if that's a rational fear or not. I'm sure that they would be up for it. And I think I will take the time to talk with them quite soon again. I think one topic that could be really interesting from them, since they are actually working together with the city of Munich, where I live currently. One topic that I was thinking about, because it needs to have something kind of novel, right? To be an actual research project. And of course, they have their existing tools to model traffic, for example, and they're working quite well for them. What? they're working quite well for them. But I think one topic that they can't really simulate yet is parking, and since that's a feature that I wanted to be important for Citybound anyways, this could be like a neat little focus subject to do a work about, and then based on this interaction I would try to see also if the city is interested, for example, and try to get some grants this way. In the meantime, like, just the technology, there's so many ways that you could use the engine of Citybound for professional use cases. But I think I really realized, I've been thinking about this a lot. Do I want to use that to like monetize it early on? But I think I really want to get it to some state where I feel like it's a game that makes sense first. And then later I can explore other commercial uses of the engine. Because for me it's really all about the game in the end. It's about, especially actually for children, to have this game where they can learn about the city, how a city works, where they can learn how collaboration works, and how all the things that we take for granted around us, like infrastructure, only exist are only possible because of planning and collaboration of people, and to experience this in an understandable, fun way. And this is really my goal number one, and I would say this is what I'm aiming for the most. Yeah, any other questions before we get started? Yeah, so I can really, let's try. I should get, I should get the habit of using this screen more, where you can just see me, because people will be able to see the chat. Actually, I don't know how well that would work on mobile, but then again, probably on mobile you couldn't even read the on-screen chat, so let's just see how this works. Yeah, did you have any ideas for stuff that you want to do on stream that we maybe never did before? Or are we fine like this? Okay. All right, so since there seem to be no more questions or wishes for the stream, let's get right into what our topic is. Well, yeah, of course, as always, great to see you, Jesse. Let me know, actually, because you've always been such a great hangout conversational partner, to the point of really almost feeling like a co-host of our Patrons Callings. If you will be around today or tomorrow, or like what would be the most convenient time, because then I will actually plan the interactive calling parts around that a little bit, because it would be great, and I think people would appreciate it as well to have you in a call. Sorry for mixing up the screens here. I still have to get used to this streaming setup. So let me just move this up. All right, that makes probably more sense. Yeah, I should really remember tomorrow to use the lower delay setting of YouTube. This 20-second delay is quite long for interaction. I'm just taking some notes on my phone here for tomorrow. Or maybe if we take a longer break later, I can reset up the stream. Yeah, what would be really interesting for me to know would be if all of you guys could tell me, I mean, today it's a Sunday for, I guess, most of you. How long, for example, are you planning to watch today? I mean, I obviously can't ask people that didn't start to watch yet, but just out of interest, assuming this is interesting, how long would you watch this in consecutively? Alright, in the meantime, let me already set up the... Let me get my setup working for the explanation part. I'll be drawing some pictures again. On my tablet, and all right, that's super interesting feedback there, Chif688. Coding, general coding practice advice as you go along if possible. I will try to do that, or just basically try to explain my reasoning while I'm coding as well as possible. Coding live streams have always been really interesting for me in the past, because even people who are not coders said, or at least some of them said, that they enjoyed. And I talked to a friend recently, because there's always these people that say that they find programming live streams really inspiring for themselves. Just to see someone else being really focused helps them to focus on something, so they're working on something else while they're watching, for example, my stream. I can't really, like, I understand the reasoning. I can't imagine that for myself, because then I would have to think about like two problems at once. But yeah, I totally get it, and I'm happy to provide that. So let's see if we can get my iPad mirrored on here. There we go. And let me see if you can see this fake iPad in here. Let me move the chat over here. And if I draw something, does that work? Does that look like something real? Because I'll be using this quite a lot to explain what we're going to do, because it's quite visual in nature, really, everything. All right, good, perfect. So, I mean, I already wrote this in my blog post, but let me just quickly give you the background again on yeah, what the situation is right now and what I want to work on. So basically, in the November prototype, what did we have working? We had the implementation of road planning and construction, like it was starting from the first prototype. We had the basic economy going with the private households as well as different kinds of companies going about their daily business. And this is what we had. So the next topic that I set for myself was to implement zoning again. And I originally wanted to do this in December. Then, as maybe some of you have read, I took on this consultancy job just to earn some money in a like really quick time, so I would have more free time later, which is actually part of the reason why I can do this hackathon now. And then I wanted to continue on zoning, and I implemented a lot of the like geometry that is necessary for that, like Boolean operations of shapes, stuff like that, which took quite some time. It's quite complicated stuff and pretty theoretical. Like, I don't think that streams on that would have been a lot of fun. And then as I tried to integrate the zoning into the user interface, based on the user interface that I had for road laying, I started to notice that a lot of the assumptions that went into the road planning didn't really turn out to be as general as I thought, and the whole architecture was really over constrained and focused on this one particular way of how I implemented roads. And what I mean by that is actually that you have the system of painting roads, and then you can select parts or even individual lanes and drag them around. And the thing is that didn't even work as well as I wanted. That was like both I noticed that both myself as well as with like both you guys, some of you who recorded videos of how they interact with the game or GIFs, as well as real people who I let it try it out, that they were actually really struggling to draw or to edit roads. That didn't really work at all as well as I thought it would. And that actually one of the older JavaScript prototypes worked much better, where you just had these simple control points. And I was thinking about this some more, and I realized that if I use that as the basis for interacting with planning in general, both for roads as well as for zones and as well as for all kinds of other things, it would become a lot easier not just to use, but actually to implement for me as well. And the more I thought about it, the more I realized how this simple model is kind of already hidden in my complicated current very, very entangled implementation of road planning, and how I could achieve many of the detailed controls with something much simpler. And let me try to explain that to you visually. And I mean, Jesse appreciates that the road system is wonderfully powerful, but what I realized is that you can achieve the same level of power with a much simpler user interface. And hopefully my plan is that, I mean, maybe that's being optimistic, but I hope that by the end of tomorrow evening, we completely re-implemented road planning and maybe even already started with painting zones. Maybe the zones don't really do anything yet, but that would be my goal for today and tomorrow. So, don't worry, Daneless, the really interesting part only starts now. So what is my new, like, general simplified idea for planning? Basically, the idea is that the main way of interacting with planning is that you have this huge canvas overlaying the whole city, overlaying the whole screen, which you can paint on directly. I mean, that's how it is right now anyways, but what I want to introduce is an abstraction that I call the gesture. And the gesture is basically a paintbrush stroke, but a more precise than a handheld paintbrush stroke. These people of you who use like vector graphics tools will probably recognize it, and I'm sure like most people who use similar games or similar software will recognize this, but the idea is that you basically draw a line consisting of some segments, basically just by clicking, and then at each segment you have this kind of control point, which you can then take and like grab around to change the line. And this is right now what kind of happens underneath the current road laying system as well. But the problem is in the way that it currently creates a curved line from this straight line, which can be really confusing. I will try to draw this for you so you understand the difference. Because what it does right now, which is really stupid and unpredictable, but it was the simplest to implement, is, okay, it starts with the straight line segment. Let me know if you can see that in orange. And just says, okay, this is straight line segment. Then it says, okay, to the next point I will create a circular arc, kind of like this. And that's cool. You could use this to draw a nice road. But then if you move the mouse to the next point to create the next point, it will again try to draw a circular arc over this over this next line segment, so that would look something like this. And this is when it starts to get really weird, because then it does something like this. And you end up with this weird noodle, which is completely unlike what you tried to show the game by drawing these simple lines. So, my new plan is to actually first make these control points visible, and to make it an explicit part of the UI. So you would see these simplified lines and these control points, and all you ever do in the new system is interact with them. You never edit the road. The road is just a result from this gesture. And this is a point that I will explain in more and more detail throughout the stream and throughout our implementation. But just one small thing to show how the new curved road will be generated from this. Something very simple, where we basically mark the center of each of these line segments, and then we start with a straight part here. We check which of these halves, like this one or this one, is shorter, and they're roughly equal, so we can leave it as it is. We put an arc in here. We do the same again here. Again, they're quite the same. We put an arc in here. And now here, like this one is a bit shorter, so we basically copy this one over here. We have a tiny straight segment here. We create another arc here, and then we finish off with a line segment. And we get a nice, curved, beautiful looking road that approximates much more what we wanted than before. Of course, the obvious question of Hannes is now, why not to use Bezier curves? Let me know, I think I'm hiding the chat under my webcam. So let me just make that smaller. How does that look? No, like this, you should be able to read it. I can make it a bit bigger. Why not to use Bezier curves? And I mean, many of the other city building games actually use Bezier curves for the roads, but they actually you don't look as nice because they can't perfectly approximate circles. In reality, what roads use is actually a really interesting combination of circular arcs, straight line segments, and spirals. And I mean, this is a bit of a nerdy detail, and I will try to get back to top it quickly. But if you would in reality build a straight road, and then let's say a straight road here, and then connect it with a perfect circular arc, if you think about driving along this road and how much you need to turn the steering wheel, basically here, let's imagine we're driving along here, you keep it straight, and then you're suddenly immediately in the curve with a certain curvature, and you would basically in an infinitely small amount of time need to like put the steering wheel like this to go around the corner, and then when you reach the end of the curve you need to again immediately put it back like this. So you have these discontinuities in the higher derivations of this curve here. So what you actually do in reality is you put like a perfect circular segment here, and then you kind of smoothly approximate this curvature. I mean, you can't really see it here. Let me draw a more extreme example. Maybe imagine like a racing track, and you have this. It's so difficult to predict. You have this more or less perfectly circular arc here, and then here you have spirals approximating this curvature. So if you go along here, you can actually smoothly turn the steering wheel. This is an amount of detail that I won't put into Citybound yet. We will do with just straight lines and circular arcs. Maybe at some point later I will add these spirals into the mix that the game like automatically generates them for you. But something like this already looks good enough and much more beautiful. Alright, so you're guiding me along perfectly with your questions. Jesse's interested how this new UI would reconcile with a custom lane-based UI. So the idea explaining this gesture system is, and for that let me actually take all of this and copy it, that, like I said, gestures are the beginning of everything, and they are just these lines which have the control points at their ends. Let me copy this and see if I can remove the I removed just all the orange bits here. So here we don't have them yet. Hold on a sec, I just want this to be a complete picture that we can come back to throughout the day as our mental model of what we're building. So we start with what I would call basically the this is the raw gesture, which doesn't really have a meaning yet. And then we basically add meaning by saying this should become a road, or like this represents a road. And the way you give it this meaning is just based on which UI tool you had selected when you were drawing this gesture. So then we do this like road-specific curve approximation kind of thing here. You can imagine that for if we were using this gesture for train tracks, we might use much more curvy curves. For zones, we can of course also use the gestures. We just draw a closed shape and that becomes a zone, and there we don't really need rounded corners. But let's now say that we're using this gesture to represent a road to be built. And then all of these different meanings for gestures have additional metadata attached to them. And for roads, you of course have, so we add metadata. So we say, let me write that down. For example, for road, right now it's quite simple. We just say on each side of the road, how many lanes should there be? So let's say 2 lanes on each side, please. And then based on this orange curvy center line, the game would create in the next step something like this. Let me try to draw this nicely. Yeah. Perfectionism. Would create something like this. Right? And this is basically the simple idea of the new algorithm. And all you will ever do if you want to edit this road is either you drag around these control points to change the shape, or you change the metadata to change the amount of lanes on either side, right? Now, where things get interesting is, and this is exactly regarding Jesse's question, how do we get the lane-based power back? I mean, the really interesting part is that you can actually overlay several gestures. So why don't we add 2 more gestures up here? Let's first think about the end result. Let's say here we actually want to have a small 2-lane road intersecting. Hold on, let me make that a bit bigger. Let's say here we have a small 2-lane road intersecting, and here we want to have just a single escape lane forking off. So let me draw the result of this. Maybe a bit like this, right? So here we would then want an intersection, right? And here, let's say we want a small lane that forks off, right? So how would we draw this? Basically, we just add more gestures in the beginning. Like we would add a second line here that looks something like this, maybe, with such control points. And then let me try to draw this again roughly in the same way here. We would again get our like orange curved center line, right? And then basically between this step here and this step here, we not only create the actual lanes themselves, but we do what we also do currently, and there we can just perfectly reuse the code for finding intersections and creating the geometry for them, right? So now we don't have the same metadata everywhere, but basically here we use the metadata. We ideally already have it in the beginning. Like we use the metadata and we generate intersections. Use metadata to create lanes, and we find and generate intersections, right? And the metadata would be something like, okay, this gesture has like 2 on this side, 2 on this side, this one has 1 on this side, 1 on this side, and if we want to add the small escape lane, we like add a new gesture here. Doesn't have to be perfectly aligned even, it can just kind of be done more or less. As long as this point here is close enough to the other one, it will actually cause an intersection. So you can see that the nice thing about this is that the user can draw stuff quite roughly while still getting the wanted precise and realistic looking result. And this would have as metadata basically just 1 lane on this side, 0 on this. So it's just a one-way road, right? Let me know at this point if this model makes sense for you for roads, and let me read the questions in the meantime. Yeah, there's all kinds of interaction methods that we could invent for, like, for example, changing how curvy a specific corner is. But for now, we'll just use this default heuristic of always taking the center line here. And then later we can make it more controllable and more fine-grained. How would I make multiple straight road segments? So basically, you draw something like this, and this wasn't really visible, let me draw a second example here so you can see how that would look. Let's say you draw something like this, and then a long straight segment, something like this, and then a long straight segment. What this algorithm would end up doing is it finds the center line here. Center line of this one is super far away, right? Here it's like this, and it always takes the shorter one. So it copies this one over here, copies this short one over here, because these are the shorter center lines, and then you end up with something like this, which is the small curve here, a long straight segment, another small curve here, another small curve here, and another long straight segment. So you see, it actually does a pretty good job of respecting both your long straight segments as well as creating nice smooth corners, but not too large curves in there. I think I explained it in a bit confusing way, Jesse, because you wouldn't. It's not like you draw the gesture and then you add the metadata and the meaning. There is basically a tool, like in a classical toolbox for drawing roads, which already you can really think about it as the kind of paintbrush that you're painting with, and this already has a current setting. So now I'm like, imagine here's a menu here on the left, and now I'm like picking up the draw a 4-lane road tool, like 2 lanes on each side, and then drawing a gesture with that, and immediately get the road that I want. And then the only question is, how do I make the UI of this menu as convenient as possible so I can have all the typical presets of like lane combinations or what I need handy, and then I just draw with that. And to draw railroad tracks, I would use a completely different tool down here, and for zones I have a completely different tool down here. So yeah, I mean, it's exactly choose road type, click, 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 is a lot faster for the same result. And then you still have the possibility to click on this gesture, like to select this gesture and afterwards change the metadata for it, right? But I completely agree that that it needs to be more efficient than drawing the gesture. Thought I had reminders put off. Well, if you understand German now, you know that I need to get a date with the dentist. Let me actually check. I thought it's in do not disturb. It is, but apparently reminders still work. Oh well. So, let me know if that makes sense for everyone, if there's anything unclear, because it will be important that we're all on the same board here, otherwise my code won't make sense. I have to say it's kind of cool to not be wearing headphones. I feel a lot more free. Alright, someone had a question completely unrelated, but what program am I drawing in? It's a really cool iPad app called Concepts. Can you see it here? Yeah, Concepts. I love it for sketches and notes of all kinds. It's really amazing with the pencil. Wholesale ripping of SolidWorks, Fusion, and Photoshop here, but you'll love it. I'll add them to the Reddit. That sounds really cool. Actually, if you want, let me know, Jesse, if you have like still 5 to 10 minutes, you could quickly hop in a call and we could discuss it, because I think it could potentially be interesting. Or if you want to take more time to really formulate it out and think about it, that's cool as well, of course. But yeah, just if you feel like a call, let me know and we can quickly settle up. All right. How do you handle cars being on the road already if you change the road? This is something that should become clear later. I mean, the way I do it right now is that if a road is in any way affected by a plan that's being implemented by new construction, all the cars on the road are being kicked off, and I forgot if I sent them back to the beginning of their trip. Yeah, I think I just let their trip fail and they have to go again, since that's something that happens relatively rarely in the daily life of a simulated citizen. That's okay. If you want to be fancy, you could actually, like much later, invent something like actual roadblocks, and it waits until the road is empty before it gets destroyed, for example. And usage is kind of the same as City Skylines. Select the tool and drag the road, yes, but with the possibility to move the road around later after you created it, and to even change its setup, so it exposes the whole underlying system actually. Does this allow for rail or other dedicated lanes to be combined on a road? I mean, that's kind of the trickiest bit. If you have I mean, maybe that even works better where, let's say you have streetcars, right? And the thing is, sometimes the rails of a streetcar or is there another word in English for streetcar? I don't know. Okay, whatever. The rails of the streetcar sometimes align with the lane of the road, but it might also go off and do its completely own thing, right? So what you could imagine here is first just drawing the road with its asphalted lanes, and then adding a second gesture on top. Let me draw it in a different color, where you might have like a streetcar coming in from here. And then it actually aligns with one particular line on your road for a while, and then maybe goes off again. And then in the end you have something like, let's try to draw this accurately, rail coming in here. I mean, you will obviously need an intersection here, but you know what I mean, going along this lane here, going off. Right? You get what I mean, right? So you would have quite a lot of freedom to combine different modes of transport. Let me remove that again for now to keep the picture simple, but you get what I mean, right? Will there be subways? Yes, and they will work much in the same way. Obviously, at some point, this game needs to become truly 3D in the way it works with like mountains and underground stuff. And again, the gestures will help us and should make it pretty easy to design that. You can basically imagine that each of the control points here also has a height associated with it. Okay. There should be some information related to each interchange. You mean like the intersections? That's one like kind of advanced thing that I was thinking about, that basically at the places where you get an interaction, like this intersection here, you can kind of paint additional metadata on top to influence how this intersection should work. Like you could kind of choose from different styles. Maybe it should even be a roundabout or something. And the basic model there is that not only you create gestures, but that the game can create something like dependent gestures, where it gives you, for example, let's draw that in like this turquoise here to represent something magic and automatically generated, where, for example, it based on the roads and lanes which you drew, it could give you the shape for the intersection as something that results from these roads, and then you can actually drag that around to change the shape and size of the intersection, or even the type. So yeah, I mean, the idea is already now that the roads can't even have completely hard corners. Like it has a minimum radius, even the road. And that's like the gesture, of course, at the top has hard corners, but then like this, what I drew in orange bits here, the roads will always approximate that with a minimum curvature. All right. What do you mean with that? How does traffic work in OpenTTD? Give me a second. I'll open the window quickly. The oxygen runs out quite quickly in this room. That's a lot of viewers, actually. It's quite cool. Okay, yeah, so let me know if you have any more questions about the general model. And if not, I will show you the like rough sketch of code that I did to implement this. And we can just continue to work on that. And yeah, with the interaction, it's always difficult. So even like if this makes sense to you, please just also write in the chat, okay, this makes sense. Or like, this kind of makes sense, I didn't understand this, or I missed something, whatever. Yeah, I know OpenTTD. I just wasn't sure what exactly you mean with how the traffic works. Like in Citybound, it's not like you don't try to earn money with the traffic, that you basically just try to make the traffic run as efficiently as possible to make the city work as well as possible. Yeah. Yeah, the delay in the chat is making it quite difficult. I will, after the coding part, after the first coding part, I will take a break and then set up the stream in a way so it's faster, hopefully, alright? Alright, perfect, thank you. Okay, good. So let's I will now not look at the chat as often because I will mostly have the code and the notes open. Actually, see if that makes a difference. I think none of you has been... Yeah, okay. So I will try to remember from time to time to look at the chat. Let's look what that looks like in code. I will leave this here and maybe do that like that. I don't need the sidebar. Like this, we should see everything at the same time, more or less. Right? I mean, remember this picture, you saw it for long enough now, and keep it in mind. I will keep the chat here. So, looking at the code, this is basically what amounts to a sketch of code, and we will complete that and make stuff work. Okay, Donnie asks, when will zoning be available in the current builds? We will, using the system, quickly re-implement road drawing and make that work. And then we will use the same system to implement zoning, which should hopefully be much easier than the first time I tried. Because it fits very nicely into this model as well. So yeah, as soon as we're done with roads, we will immediately do that. So, getting into the code. Like I said, our main abstraction is the gesture. And a gesture obviously consists of points, which this means they are a vector, so like a collection of points, of two-dimensional points so far. And a gesture does not only have the points, but it also has a meaning, what I called intent. And as you can see here, the intent can already be one of two cases. It can either be a road intent or a zone intent. And if we look at the bottom where that is defined, you can actually see that a road intent has exactly the number of lanes forwards and backwards. So on each side of the road, just as an unsigned small integer. I don't think we need roads with more than 255 lanes, so that should do as well. And here you can already see for the zone intent that each zone shape that you draw can also have different meanings again. So it can either depict a land use, where land use is like residential, commercial, industrial, you know. or it could be limiting the maximum height of buildings or determine a specific setback in this area. And I mean, we will talk about this when we actually implement zoning, but the idea is that you don't draw a zone shape and say, okay, here's residential with this height and this setback, but that you draw one shape that specifies the land use, another shape that might like overlay it but not be exactly the same, that specifies max height in some region, and another one that specifies the setback. And then from the combination of these zones, kind of like overlaying colors and shining light through them, you get the number, the set of restrictions at each point on the map that developers of buildings have to pay attention to. But for now we'll focus on the roads, and our road intent just consists of the number of lanes on each side of our gesture. Now it gets into the basically orchestration and organizational part, and before I start with that, let me close the window because now it gets cold. It's actually started to snow again after a really long time of basically spring here. Hold on a sec. Alright, continuing with what is actually a plan. And the interesting thing is that the way that the like most basic underlying concepts are implemented in the code completely determines what the UI can support and what the game can be. And when like I sat down now to really find a simple model, it was really important to me that this would already naturally support all the things that I had in mind for collaboration of players and for working on different plans for the same city at the same time. So, in a simple sense, a plan is just collection of gestures, right? And this is kind of what you can see. For now, imagine this just says a plan consists of a bunch of gestures. Again, gestures are these points representing these lines associated with a meaning that actually makes something real be created from that later. Now, how do we represent everything in the game with just one player first? So the idea is that there's always one kind of master plan that represents everything that already has been built. So this is like an actual plan containing every single road, every single zone, every single train line, every single whatever else you will be able to draw with gestures in your city in one huge plan representing what exists. Now, if you start actually planning a new plan that represents a change that you want to happen in your city, like a new road, a road that is deleted, a road that is changed, then this is also a plan, and what you want to have in the end is kind of the combination of the plan of everything that already exists, plus your new plan, which I call a proposal, and merge together where the changes of the new plan override whatever exists in the old plan. So adding new gestures is quite simple, because you just add them to the old plan and then they're there. But how do you deal with the fact that you maybe want to move a control point of an existing road and have the change of that represented in a change proposal? And how do you deal with the fact that you want to completely delete the gesture and thus the road that it represents or the zone that it represents? So the system that I came up with is something pretty simple, where a plan is not just a like anonymous collection of gestures, but each gesture actually has a gesture ID, which, if you look at the implementation here, is actually a universally unique identifier. And let's actually do some learning and go to Wikipedia, or basically just Google UUID, and see what that's all about. And the neat thing about a UUID is that you can basically, it's a ID to represent something that you can either generate according to some specific rules, like it uses the MAC address of your computer and the current timestamp to make sure that it's unique. But you can also just, here, version 4, if you use version 4, it means that it's a completely randomly generated number. And every time you ask for a new UUID, you will get a new random number. But because they're so long, they're 128 bits long, the probability that you get the same UUID twice is really low. So you can just, every time you create a new thing, like a new gesture, you can give it a UUID and know for sure that this UUID actually uniquely identifies it. And to show you just how small this number is, they say here, here for this version 4 randomly generated UUIDs, to have a 50% probability of having at least one collision, so accidentally generating the same UUID twice, is this number. Like this many, you need to generate this many UUIDs to have a 50% chance of having at least one collision of them. And then it says here, and I mean this is a tangent, but I really like to think about these things, just it makes us understand how crazy computers really are. This number is equivalent to generating 1 billion UUIDs per second for about 85 years. So this is how many of them you would have to create to get only a 50% chance of having one UUID appear twice. The whole point being, you can really trust them to be unique. And that's why we say that a plan is a map from a randomly generated gesture ID to a gesture. So our plan is not just an anonymous collection of gestures, but each of them actually have a unique name, the gesture ID. What does that make possible? What that makes possible is that plans can refer to the same gesture but have different opinions about one gesture. So let's say you build a road and it now exists in this what I call the master plan of what exists. And it has a certain shape there. And now you go ahead and you want to change one curve a little bit. So you drag the control point and then, okay, my iPad switched itself off. And then you basically have a plan proposal representing that change. And what that would look like in code is that you, in the change proposal plan, for the same gesture ID, you have a different gesture, right? And then when you say, okay, I want to implement my change now, you can exactly see that these both plans, both the plan representing what exists and the plan representing your change, talk about the same gesture but have different opinions, and you want the change to override what exists. And this is what this function here is for. The definition here is, the types are a little crazy, but basically what this allows you to do is to take an existing plan, which is called self, and an iteration of other plans, which can be basically a list of other plans of changes that you want to apply to the original plan, and it gives you a new plan. And I mean, what it does in code is just, it first just clones the original plan, and then for all the gestures in the other plans, it adds all the new gestures, and it replaces all the gestures that changed. So like this, we have a really simple way of merging plans, and what that means is that we can't just have like one change that we apply to whatever exists, but we can have people working on different plans at the same time. And you could even have plans that, like, this guy decided this road should go like this, but this guy moved it differently. And then when we want to implement both, the game could tell us, kind of like in version control systems for programmers, look, there's a conflict here. Like, this guy wanted to do this with this road, this guy wanted to do this with this road. Choose which one you want. And all of that just because each of our gestures has this truly unique name that will even be unique across machines. And yeah, that's just a very neat way to do it. So, but how do we then represent when we want to completely delete something? Because if we just have it missing from our new plan, it will just stay. We just add all the new or changed gestures to the existing plan. But if it's just missing from the new plan, we don't really encode the information that we want to delete that. So that's why gesture actually has this field deleted here, which can be set to true, which means for us we should interpret this gesture as if it doesn't exist when we create the roles. But we have it so we can represent that a plan wants to delete an existing gesture. And it even still stores its point and its intent, so at some point in the future we could even say like, hey, I want to undelete this road from earlier actually. Let me know if that makes sense so far. Okay, again, if it makes sense, okay, cool, thank you. Sorry for the delays, I just want to make sure that I'm at least not losing everyone. So let's look a little closer at what a proposal actually is, because, I mean, strictly, a proposal is also just another plan, right? But if we think about the user interface, as we're editing a proposal, we actually want to be able to undo and redo stuff, right? So this is why actually a proposal is a history of plans, where every time you change something, we duplicate the plan of your change and add the latest change to it. So if you don't like it, we can just say, oh, let's undo that. We throw away this part of the history, go back one step. And this is basically what this proposal structure does here, where you can create a new proposal, which is just empty. You can add one change to it, and even a single change of like adding one road or moving one control point is in itself a plan, right? Just contains one gesture. And then we have undo and redo, and we have this apply to, where we can take the whole proposal and basically, sorry, I misexplained it earlier because I recently re-implemented that. The history is a collection of plans, each representing one change step. So for example, the first one might be we create a new gesture. And then the next one is, okay, now we modify this gesture, so we have a new plan with the same gesture ID but a different actual value for the gesture. And then we add a third one. And to get the resulting plan, what we have to do is to add up all of these plans according to our logic of merging plans. And this is exactly what we do here. And then we apply that to some base plan like the existing reality. So we basically take the base and merge it with all the tiny plans representing individual steps in our history. It sounds greedy. Will it add to memory usage? Not really, because whatever plan you're currently working on is kind of limited in size, right? And even if you like, let's say, plan a whole airport or a whole new quarter of the city, that's still, let's say, even if you add 1,000 new roads, and each of them have, let's say, 1,000 points each, the memory which you need to represent that is still a couple megabytes, basically. Yeah, I misexplained it. It doesn't copy the whole plan for every step in the history, but each step in the history just represents one change. So if you have a road and then you change it once and then you change it again, okay, you have this road 3 times in memory, but that's still not too bad. Like, this is really doesn't take a lot of space. And as soon as we implement the proposal, we can of course merge of them and basically keep only the latest version of each road, right? Does that make sense? And this is what I put here in the note. When applied, proposals can be flattened into their last, into, let's say, the last version of each gesture. Yeah, but my point was that even if you have 1,000 roads and you change, and they're like super long each, and you change them, it's still only a couple megabytes of RAM. So you could scale that up by a factor of 100 or even 1,000 if you have a spare gigabyte just for planning, and you're still fine. Okay, moving on. This basically establishes kind of our theoretical framework for thinking about plans in general, right? And now it becomes more and more, it gets more and more to, it becomes more and more an actual implementation. And here the plan manager is kind of one central actor that takes care of planning. And this is already written with multiplayer in mind. The idea is that you have one instance of that running on some computer, ideally the beefiest one, and that takes care of all of the planning. This is my planning prediction, yeah. In the future, I would like to distribute that even more across the machines, but right now it really helps to have everything in a central place, and even that should scale to quite large things. Like I said many times, here we have our master plan representing what is currently actually built in the city. Then we have a bunch of proposals where basically each new project, each new change that you want to do has its own proposal. I mean, maybe we can also call these projects. Let me know what you like better. For now, I will call them proposals. Then we can even keep the implemented proposals just for future reference. Maybe we want to like look at them again. Maybe we really liked some intersection that we built on some part of the city and we want to copy paste that just in an isolated fashion from one proposal, not from the whole plan. So why not to keep them around, right? And then we have the UI state representing how different people currently interact with these proposals. And this is why it's actually a map of machine ID to a plan manager UI state, because each player gets their own UI state. So what's in the UI state, it remembers the number of the current proposal. So which of the proposals is this player currently looking at? We maybe, this is why it's an option, we maybe have a current preview of the like result, like a preview result of applying this proposal to the current reality. And then we have like the renderer and the user interface on that particular user's machine, so we can draw stuff there and interact with their mouse stuff, right? I hope that makes sense so far. Now the central UI element will be, and this is basically where I stopped yesterday before the stream, is the gesture interactable, which is an actor in itself, and it takes care of the UI of one gesture and its control points. So what does it need? It needs to know which proposal is it from. It needs to know it needs to know which gesture ID does it represent and what is actually the gesture, so it can draw its point at the correct time. And I started here with stubbing out the interaction. So what if you click on any point on this gesture and start dragging it around? What should happen? And this is what we will fill out first, because it will really tie together what the user does with our theoretical framework here. Then we will continue with implementing the rendering for the gesture. So we actually draw the lines and draw the control points as just simple dots first, and later we can invent something more fancy. For now, they will just be simple dots. And then we will try to actually connect this, what is a new file here, if I open the Explorer, you can see that we have actually planning new and planning old. Planning old is the existing system, and I'm completely replacing that by something new. We will copy over stuff from here later, but the idea is that we will have for some time both of them in parallel in the game until the new part can do everything that the old part does, and we can actually confirm that by playing around and comparing them, and then we just throw the old one out completely once we're done with that. All right. We will not do yet the connection between, we will not do yet the part for implementing plans. That will be a little later. Hopefully we can also get there today. For now, we will just create the UI for creating and manipulating plans, all right? Okay, I'll just take a 2-minute break and eat a little more, drink a little more before we get started with the coding. If you had any questions so far, any comments on this theoretical framework and how I laid it out and what we're trying to do, let me know, and then we will get right into it. I hope you don't mind me eating yogurt on stream. My sleeping schedule is a little out of whack already, and I didn't really manage to eat it all before the stream. And I'm trying my best to keep myself in a workable state. And whoops, what happened there? Oh, I just completely disconnected the iPad. Actually, this. Okay, so yeah, it will be quite interesting for me for how long I can do the stream. I mean, like I said in the beginning, my plan is to do the intensive coding part first. Now we had quite a long intro, and just keep doing that for as long as I can bear. And then when I can't concentrate on coding anymore, I will switch over to the more to the kind of discussion part. Later on. All right, any questions, any comments? And also, yeah, you can see all of the stuff is in one file right now. I like to start like that, so I have everything together, and then later on I will split it up into topics. Will this support Linux? The previous prototypes, in fact, already support Linux. Citybound is always compiled for all 3 platforms, Windows, Mac, and Linux. I'm only really the way I deployed is just to give you an executable for x86 platforms, like no nice package or something for Ubuntu, because I just don't have time to do that for all platforms. But it's something that you can basically download and run on most Linux flavors on most computers nowadays, and I always try it inside a virtual machine because I don't have a full Linux installation going constantly, and there it works, and it seems to work mostly for people. It's probably my least supported platform, but I definitely support it, and if I have more capacity for such stuff in the future, I will try to make that a little nicer. Alright, of course there should be some logic for clearing memory, I guess, in the future. Yeah, I mean, this has kind of to do, the only thing that you can really clear is the proposals. You can flatten them into their last steps, but I like to keep everything around. Like I said, even the plan representing the whole city, I mean, it's something that we need anyways, because any new roads that we add need to interact with the existing roads, and for this reason alone we need to have one plan that contains everything. but even this should really not be memory intensive, even for huge cities. And as soon as that becomes a problem, I mean, this will always take much less memory than actually the simulated citizens and traffic and everything. But as soon as this stops scaling, because it's right now centralized in one single place, in contrast to traffic and simulation, which is completely distributed. So that means that if the traffic and simulation and all that stuff and the economy becomes too large for one machine to handle, it works flawlessly across several machines and can use the additional resources, where this works across several machines, but it's actually all stored on one machine, and as soon as it doesn't fit there anymore, we got a problem. But even then, it shouldn't be too difficult to like split up different parts of the city and have the master plan for that on different machines, for example. That will be more complicated, but not too complicated. All right. So let me quickly connect my iPad again, just so we have a visual reference for what we're doing. There we go. So let's assume for now we're implementing this gesture interactable. And so we're now implementing how you can change an existing interactable. So let's first start. We have this ongoing drag event, which is quite useful because our interactable will gets that sent from the engine as the drag is ongoing, and the whole time you have both the starting point of the drag as well as the current ongoing endpoint of the drag, which is really useful to represent the whole change. So basically, first we just deal with moving existing control points around, and later we can think about, and I would start just with that. Later we can think about how we can add and delete control points in the middle of the gesture. But let's just do that first. So we will try to find the closest control point, or if there's any control point that's kind of close to the start of our drag. So if some closest control point is found when we do self, I don't know why I don't have autocomplete here. Probably something is so broken that I can't do it. Let me quickly fix the mistake so we actually get full autocomplete here. Okay, so do we? No, we still don't get that. Okay, whatever. So we are a gesture interactable. So if self gesture, yeah, we can read your message. Self gesture points. If we look here, points is our vector. We want to iterate over them, and then let me pull up the Rust documentation here. There's on iterables, there's a find function, which just takes a function. Actually, here iterator find takes a function that represents a predicate and runs over all items and returns, maybe this is where it returns an option, returns the first item that matches that predicate, right? So we do self gesture points iterate, and then find, and we look at each point and we see if this point is roughly within, and for that we will need to import something from our geometry library to get like approximate equality of two-dimensional points. So if it's roughly within our point where the drag started here, and we will define a control point handle radius and I don't know, let's choose each control point is like 5 meters big in the game. So if it's within, or the radius, let's do 3, so it's like 6 in diameter. Later we can invent something fancier, because probably when we zoom out we want the effective control point radius to be bigger. Basically we want it to be a constant size in 2D. But that will require a little more complicated logic here, because we basically have to convert the points in the 3D world onto 2D points on the screen, and then see if it's within a 2D radius on the screen, and then it would be truly independent of zoom level. So for now, we're just looking in the 3D world, the point where you started dragging in 3D, is it within these 3 meters of our control point? And if yeah, this is what we want to know. Is it roughly within? If yes, then this is the point that we wanted to find, and this is what we have here as our closest control point. So if there is some closest control point, then what do we want to do? We basically want to create a new gesture. And we actually don't want to know. Okay, no, we want to know the point and also the index of the point, I guess. Like, is it the third point in the gesture? Can we do that? I think that's position. Yeah, we want to know, we don't want to know the point, but we want to know the position of the point within, whoops. So that's the index of the closest control point. So alt point is self gesture points and then the closest control point index, right? Then the new gesture is create a new gesture. Points is let's create new gesture points, and that's mutable is self gesture points clone. So we clone it and then we replace the point new gesture points at closest control point index is alt point plus basically 2 minus from. If you think in vectors, we want to move the alt point by the same vector as our drag start and our drag end. Does that make sense? Alright. So these are all two-dimensional points. This here is a vector. That should all work out. So we create a new gesture where the points are our new points, or our new gesture points. And then we can actually just do self gesture clone, like everything else we take from the existing gesture, right? Okay, so far so good. Now we need to tell our current proposal, and now it gets interesting. This is something that I didn't implement yet, and I will need a minute to think about that. Because sure, our proposals have this nice history, and we can push a step onto the plan to create a new point in history. But while we're dragging something around, we don't want to create millions and millions of steps for every single pixel movement of our mouse, right? So what we want to do is to have kind of two different modes for affecting our proposal. First, we want to be in a preview mode where we change the last step in history live, move it around. And then when we let go of the mouse, this is when we say, okay, we're actually done with this change and we want to add a new step. So we actually don't want push here, we want two different things. First one is start new step. And what that does is first we do the self history truncate. This basically deletes the redo history. We self history push and we push an empty plan. This is our default step, and we do that to keep track of where our undo history currently is. Okay, and that's one part. And the other one is basically set ongoing step. Yeah, set ongoing step. That sounds like it makes sense for me at least. To a specific change, which is a plan. And what we do there is just self history at self current length. So that refers to the current step in history that we're working on. That should become the change. So we can, in an ongoing way, change the current step. Then when we're done, we do start new step, and this is kind of baked in, all right? And we need to, in the plan manager, we need to have corresponding message handlers, because the plan manager is really the actor that can take messages from everywhere. So we just copy that, we do start new step, and we take just the proposal ID, and here we actually don't need to change the, maybe we do, I don't know, okay. And we also need the set ongoing step self proposal ID. The change is plan. Well, let's actually make that even more explicit and call it current, yeah, current change. Like this, and then here we have the proposal ID to know which proposal it should go into, and the current change, which is a plan. And we don't need to communicate with the world, so we don't really care about that. So self proposals proposal ID set ongoing step with our current change, and then again we should probably put this into a helper function. Clear preview, yeah, clear previews, where we delete the preview resulting plan on all spectating players' machines. So self clear previews, okay. I think the autocomplete engine is just completely broken, so let me reload this window here quickly, and that should fix it. Let me know if that kind of makes sense for you so far. That's always really important for me to not completely lose you. Or if you feel like you want to know why I do certain things in a certain way. I forgot who it was, but someone asked for like general programming advice. I'm more than happy, and I'm trying to give my motivation as I'm going, but I'm so deeply into this that I can't really know for an outsider what is a surprising decision. Okay, cool, thanks for letting me know. Right, cool, so now that we're handling this properly with the new step and the ongoing step here, while our drag is ongoing, we can actually send the proper message here. So since oh, and the interactable also needs to know which plan manager. I mean, there's only really one, but it still needs to have its ID, basically like an address to send messages to, right? So it needs to have that. So what we can do now is self. Oh, and now we get the autocomplete. Perfect. Self plan manager, and then we do set ongoing step. Self proposal ID, and the and we need to rob current change is a new plan where gestures is just can I create that from an iterator? I need to check that quickly. By the way, all of this compact hash map here was actually created not by me, but by a collaborator on GitHub, which I thought is really cool because it's quite complex low-level stuff. And it works really nicely and was helpful in a lot of places already. And he managed to do it completely in the same style as a lot of my other code. On default from iterator. Okay, so we can do that. So let me just quickly look how that convention works from iterator. And I think that allows me to do this gestures is basically just one gesture with our self gesture ID and our new gesture. So it's a pair of gesture ID and gesture, and then we do collect into collect. Not the nicest way to write that. Maybe I can find a cleaner way. So now we have our current change with just this one gesture change represented as a plan, and we set that as our current change to our plan manager, right? And that should do the trick. Let me see. Okay, here we need to say that this is a number from our geometry library. Let's see if every time I save it compiles it and shows me any errors. We don't have any errors. Oh, we have errors in this file. So yeah. First we need to add default for plan, so it can have an empty plan. And then we, like I said earlier, need to import roughly comparable from our geometry library, so we can do this finding of the closest control point to our drag start. Oh, but our drag is actually a 3D point, so we need to convert it into simple. We just don't care about the third dimension, basically. So then I also need to import into 2D. What does it complain about here? Oh, also this distance should be converted to 2D. Alright, no more errors in this file. That looks good. So now we basically implemented the logic for the ongoing drag. Now, now we need to refactor this a little bit because we want to handle both the ongoing as well as the finished drag. And most of it will be the same, all of this here, except the last part where in one case for the ongoing drag we want to set the ongoing step, and in the other case we want to just set the ongoing step once more and then start a new step. So if you don't mind, I want to ask how much time have you spent for this game? Several years. 4 years, I think, so far. Definitely not always 100%. There has been long periods where I could do it only little or not at all, but it's been going on for quite some time, yeah. So, let's just simplify this a little bit here. So we will always have our from and to, and we want to know if our drag is drag ongoing. Then we match our event. If we have this, then we have from to true. If we have event 3D drag finished, from to, we don't care about the rest, and that take from to false. And if our event is even a drag, so let's swap that in an option, some and for all other mouse events, which we write like this, just I don't care. We don't even have any drag ongoing. Let's drag info. Then if let sum equals drag info. So if we have a drag ongoing, then we do, if we have a drag ongoing or finished, then we do all of this. And let's introduce another variable to make the syntax cleaner. Maybe closest control point index is this stuff. And then if the maybe is actually some, we do this, right? And then we set the ongoing step always to add the latest change. But if the drag is not ongoing anymore because it's finished, well, let's actually flip that around. So is drag finished, and then here while it's ongoing false, while it's not ongoing true. When it's finished, it's true. So if is drag finished, then we also start a new step, right? Start new step in our proposal ID that this gesture interactable belongs to. Okay, that should be a pretty solid implementation of the interaction of dragging around existing points. Next, we need to implement adding new gestures and adding points at the start or the end of a gesture. Let me think. how we will do that. But I think I know. Just give me 1 minute to think about it. In the meantime, feel free to give any comments. Ask me anything about what we're doing so far. By the way, I really missed this, and I really enjoy this process of thinking aloud while I'm programming. I really can't judge if it just sounds like complete random rambling for you, or if it's cool. But it's quite a lot of fun for me. Can't really tell if I prefer it to working silently. I mean, usually I always work silently, and I recently talked with some friends about this, that if they're alone, they really like to talk to themselves while thinking about programming or implementing something. I don't do that. I'm always silent, even on myself. But I also don't mind talking now at all. It's quite nice. I couldn't really say which I prefer. Tomfu joined a little later, so can anyone explain what a gesture is? Let me try to do a quick rundown. I will show my iPad again. Just 1 sec. Here, can you see that, Tomfu? Gestures are just these basic lines here with control points at their corners, which the user can create and drag around, which then represent stuff that you want to create. Like these lines all represent roads. And you can kind of see the steps here in which roads are created. First, you create these orange curvy lines from the straight lines, and later you create the lanes and the roads and the intersections. And we currently implement the UI for drawing these gestures. We right now first just that we assume there already is a gesture with control points, and we implemented the logic for dragging the existing ones around. Next, we will think about how to create new gestures and how to extend gestures by new points. All right. As a quick summary, Noab asked, if you encounter Rust errors, could you leave the error screen out for a few more seconds? I don't know Rust, but I'm interested, and that error looked scary, that you understood the issue in a snap. Could you tell me at which point that was? I would like to see more if they're really that easy to parse. Earlier there was quite a scary looking one about the geometry where like throws a quite complicated type error because some of these vectors are actually in 3D space and some are in 2D space, and the underlying geometry library which I use represents that as types, which is cool in itself, but it creates quite long errors. And the other errors, yeah, next time I encounter one I will try to remember to actually show it and explain what it means. Cool, that's really cool. Yeah, I'm quite happy. I mean, Rust can be really technical and low level at points, especially when you get into more complicated type stuff or generic types with iterators and references, and borrowing is of course the most difficult topic, but most of the time it looks really clean. I mean, yeah, it does look really clean. So let's think about how we want to create new gestures and extend existing ones. And for that, let's create a new interactable, which I will call the gesture canvas. Wait, we already have that? No. Okay, that's weird. So the gesture canvas will be a canvas spanning the whole game world, where we can click wherever we want. To add new control points, and then we have to add some logic whether we want to add this control point to a completely new gesture. like create a new gesture from one point, or whether we want to add it to an existing one and then to the end or to the beginning or what. Something with from, it was probably this this stuff here where I want to create a hash map. Like, remember that in a plan, gestures are a hash map from gesture IDs to actual gestures. And I mean, I don't know which languages you're familiar for. I will explain this because I think it's interesting to know. For example, in C++, you have constructors which can take a variable amount of arguments, or can take a list as an argument to create a new hash map from a list of key value pairs, for example. Rust does it a little differently, where if your collection implements this from iterator, then you can define how to create this kind of value from an iterator of a certain kind. So here we define how from an iterator of our key and value type of our generic map, we create a new hash map. And you can, if you look at the code, it's quite straightforward. First, it's pretty nice because it doesn't have to be an iterator yet, just something that can be turned into an iterator. So you could pass it a list, because the list can become an iterator. So you create the iterator, you create a new empty hash map with already the correct capacity if our iterator knows how long it is. Not all of them know. And then for each key value pair in the iterator, we just use our map insert function, and then we can now construct. So what I'm doing here, it's not clean. I'm using an option, because an option can actually be turned into an iterator. So that's basically just a way to represent a list with one item. I could also, let me see if this also works. I can actually also probably create an array with just one item. Yeah, that also works, and that's probably cleaner. Sometimes I like to use options. No, because then we only get a reference here. So let's keep using the option. All right. But basically, we use this trick here to create a hash map from a variable number of arguments. I just like this slightly better than having to write here, create an empty hash map, and then insert this new gesture. Just a bit cleaner in my taste. But whatever. Back to topic. But I appreciate such questions, and I'm happy to go take a couple minutes to go into a little bit more detail for educational purposes. Let's derive compact and clone, because we need that for everything that wants to be an actor. Our gesture canvas will also be an actor, so it has an ID. Because basically each player will have their own gesture canvas on their screen. And what does it need to remember? It basically has a state, current mode, and then gesture canvas mode, and we define an enum gesture canvas mode, because basically there's 3 ways in which we might want to add a new control point, which is basically start new gesture, which doesn't have any data associated with it. Or add to end of existing, and then gesture ID, or add to beginning of existing gesture ID. So this is kind of the 3 simple states that our canvas can be in. Yeah, really don't be sorry. I think it's this is a complicated step that I just glanced over really quickly because it's something I do all the time, but these are exactly the things that are not straightforward for people who are not already very familiar with this. So it's good that you asked, actually. So that describes our canvas. Now we will again make our canvas an interactable 3D for gesture canvas, and we will, yeah, okay, let's do that later. Let's just think about the canvas now. So on event, and for our canvas we really only care about clicks, right? Whenever we click on the canvas, we want to add a point in one of these modes. So the way in which I represent clicks in my UI library is not at all. I basically just say, well, a click is just a very short drag where you don't really care about. You only really care about where the drag started. You don't care where it ended. It's just a short drag. So, and we care about the moment when you press the mouse down. That's when we want to add a new point, right? So if if it matches to drag started actually, and drag started only has at. So this is basically a click. It's just the start of a drag, and we never care about where you drag it. We just care at the starting point of your drag. Matches our event. Then what do we want to do? Let's first do the match self current mode. If we start a new gesture, then what do we want to do? We create new gesture. We create a new gesture with a single point. With a single point, which is exactly our point. Add into 2D. Oh, yeah, that's correct. Add into 2D. And then we convert this into a compact vector. Not really that important. If you want to know about it, ask me. Our intent for now, let's keep that fixed for now. So our intent is gesture intent road intent end lanes backward to end lanes forward to. Let's introduce a shortcut for that. Just so we can write it more compactly. Okay, so now we can just say road intent to 2. So let's actually do 8. So for now we always create gestures which represent a two-lane road, okay? And then we need to our gesture canvas is also for a specific proposal. So let's add that. Okay. So we create a new gesture ID because we're starting a completely fresh gesture. And that is actually the point when we create a new UUID. And this is really the point where the UUIDs start to change. Like there's no central registry for gestures needed. We don't need to ask anyone to give us the next successive gesture ID. No, in this completely unrelated part of the code, we can just conjure up a gesture ID from nothing and be sure that it will still not conflict with any existing gesture IDs, just because the probability is so astronomically low. Can someone please fill in Killer Mapper really quickly? That would be super nice, thank you. We have the new gesture ID. We create a new step, which is a plan from that. And again, gestures. And we do again the same trick as earlier. We create a key value pair with the new gesture ID. New gesture into iterator, collect into a hash map. Okay. Here we also need to have the ID of our plan manager, so we can send it messages. Plan manager ID, and then we can send a message to our plan manager. We set our ongoing step because we always assume that we're in a fresh state, basically. We are in a fresh state. We set our ongoing step to this new plan. Self-proposal ID, new step. Okay. And then, I mean, after we create the first point, that's already something that we want to be able to undo. So we also start a new step immediately, right? That's not like an ongoing drag, it's just one event where we like add something. So we set the ongoing step and we start a new step. Okay, that's good that it sounds like it makes sense in code as well. Okay. So, and then what do we want to do after we created the first point of a new gesture? We basically want to switch the mode of our canvas, that the next point which we will create will be added to this new gesture, right? So, and this is again where the gesture IDs really help. We just created this new gesture ID. We are actually the first one to know about it. So now, of course, we can simply say self current mode should be add to end of existing. We assume that this gesture is now existing gesture, then of the existing new gesture ID. The next point which we will draw, we know that we want to add it to a specific gesture. Okay, let me think. We will probably need to extend we will need to let me think. I mean, if we created the first point, as we are like moving the mouse around, we will want to get a preview of of what we're about to draw next. Give me a moment to think about that. Yeah, Killer Mapper, you will be really happy about how the new system will work, and thank you, by the way, for the summaries. This is quite a nice summary. I think you will really like the new system. It's a lot more intuitive and predictable, and it actually at the same time also makes the code simpler. So the problem which I'm having now is that, okay, first point, fair enough, but for the next points, this gesture canvas would somehow need to have information about the existing gesture beyond its ID. All we have is the ID, and we don't want to have that. Don't want the canvas to have a memory of all the gestures and all proposals. So okay, let's do things a little bit cleaner. And define actually some operations on proposals. So this, I mean, start new step and set ongoing step is super generic. Let's actually, okay, we can get rid of this first, and let's actually define concrete concrete operations, which we can do with the gesture. So what do we have? Start new gesture. And that just takes a single point actually. And let's do it with a clean interface like that. So there we can do what we did here. I don't know what you've decided about terrain, but if you plan to include it, shouldn't that be taken into account here? Yes, terrain won't be included. Yes, so far everything is 2D flat cities. In the future, when I include terrain, all of this here will become relevant. The gestures will get 3D control points, not just 2D points. And height and interaction with the terrain will be taken into account when creating roads. For example, then you also need to check, can you even build a road there? Is it too steep? Do you need to create a tunnel and all that kind of stuff? To keep it simple for now, we live in completely flat cities, okay? Okay, so start new gesture, new step, and then we can reuse our more generic. We do set ongoing step, new step, and immediately start a new step. Okay. What else can we do? Earlier, let's actually also move this in here. Move control point. We need the gesture. We need the give me a second. What is the cleanest way to do this? This is maybe not the correct place to do that. We will leave it simply. Sorry for the confusion. This should actually be in the plan manager. We will probably not need these. We start a new gesture in a specific proposal. So self-proposals. Proposal ID. Okay, this feels like at least some form of testing would help you a lot. Yeah, but this is really simple stuff. I mean, I can imagine the interactions between different parts in my head. Of course, later when we all hook it up together, very often with games, like the real implementation and the real UI is the best test. But right now I'm comfortable just doing it with imagination. It might give me the occasional minute of confusion, but I feel like it will take me a lot more time to set up tests for that. So yeah, just my style. And even for the tests, I would have to decide on an architecture, and that's the difficult part here. So start new gesture. Easy, we can now use this here. We don't need to have all of this logic in here. We basically only do this self plan manager. We need to save it at least once. So we can start new gesture, self proposal ID, add wherever we clicked. Okay, good. So now it gets more interesting, and you will understand why I'm starting to move stuff into here. Oh, okay, and we want to already have to be Okay, good. So this was the easy part. Now add control point is more interesting. Again, in a proposal, because now to add a control point, we basically need to get the existing gesture. to be able to change it so it contains a new point. And this is why we need to do it here in the plan manager, which has access to all the build gestures as well as proposed gestures. And you will see in a moment what I mean. Gesture ID. The new point. Sorry about that. Add to end. This is a boolean. Okay, so add control point assumes that there is an existing gesture. The problem is we don't know, is this gesture a part of the existing UI, of the existing build stuff, or is it a gesture that has only been introduced in our proposal? So what we actually need to first get is the existing gesture, or like, yeah, current gesture. So for that we take our proposal, apply it to our master plan. So now we have the combination of our master plan and our proposal, and then from that, the gestures, we get the one with the gesture ID, and we will be sure to have the up-to-date version of this gesture. So this is a kind of naive way, because we need to calculate the whole merging of our current proposal with the master plan when we really only care about the current version of one gesture. So we'll just add here as a to-do note, introduce more efficient way to get the most up-to-date version of just one gesture. But it should do the correct thing even if it's horribly inefficient, something that we can fix later. How's the saying always? First get it right, then get it fast. Right. So current gesture, and the change gesture is, well, if we add it to the end, it's a new gesture with the points of the current gesture, points iter cloned chain, an additional one in the end, our new point, and collect it again into a vector, and the rest we just take from the current gesture. Else we add it to the beginning, so it's kind of the same, only that we start with the new point into iter chain, this stuff cloned, and collect it into a new list. Okay, and then we can take this from here. New step is again our key value pair, the change gesture, and then self proposals, proposal ID, set ongoing step, new step, no, new step, and then we immediately commit our change by starting a new step immediately. And you understand that we needed to do this here exactly because to get the current version of a gesture, we need to have access both to the master plan as well as to the proposal to really, get the latest version of this gesture. Save that, see it nicely formatted, see if we get any compile errors in here that we might need to fix. Oh, okay. First here, to show errors, expected reference found struct. So I give it directly the plan, but the apply to function actually just expects a reference. So it actually shows us which type it expects, so we just take the reference. Now the next thing. Here I write, let's wait for the errors to appear again, current gesture dot points. What does it complain about? No field points on type option of gesture. Wait, I thought that current gesture is a gesture, but this here tells us that it's an option. Oh right, gestures is a hash map of gesture IDs to gestures. If I look at the get function, see here the implementation, I give it a key and I get back an option of the value because maybe there isn't a value for this key in our hash map, right? So this is actually a gesture. Now, if we think about it, if we can't find a gesture with this gesture ID, then whoever sent us this add control point message did something wrong, because how can he want us to add control point to a gesture that doesn't even exist, neither in the master plan nor in the proposal? So we really expect that it should be there, and otherwise we want to crash the game, because this is something that should never happen. It means that there's a bug somewhere else that we want to find. Luckily, Rust has this cool expect function on options, which basically says like, no, I really expect this to be some and not none. And I can put here an error message, expected gesture to add, expected gesture that point should be added to exist. And now if we can't find the gesture with this ID, it crashes and it will help us to find the bug somewhere else, which hopefully should never happen, right? Makes sense. And here you can see that current gesture is actually a reference, and we want to get a value from that, so we need to clone it in both of these cases to construct our new gesture. Okay. To get a value from a reference, you need to either take ownership of it or clone it. We don't want to take ownership because the gesture exists elsewhere and it should stay there, so we need to clone it. Missing field deleted. Let's actually add a constructor for gesture that allows us to create it more compactly. So what does it take? Takes points. And then intent, gesture, intent. And when we want to create a new gesture, it's not deleted, right? So gesture points intent deleted false. And then when we create the gestures for the first time here, we can do it more succinctly like that. Okay, let's see any more errors. What's happening down here? We wanted to change the interface here. So we have start new gesture, add control point to start or end. So we can now use that in our canvas implementation. So if our current mode is add to end of existing gesture ID. Yeah, expect is really cool. It basically allows you, like usually you should always handle the case if an option is some or none, obviously, because most of the times that represents situations where you say something like, hey, give me the first element of the list, but what if the list is empty, then it doesn't have a first element and you need to handle both cases properly. But sometimes, like in this case, it's really clear that one of these cases can happen in theory, but it shouldn't happen. It represents an error, and that's when you can use expect. So if we are in the add to end of existing mode, then we do self plan manager add control point, add into 2D, where we just clicked first our for the correct proposal ID, add into 2D our gesture ID, which we remembered. Other way around. First gesture ID, and the new point. You can see this helping me here. Add it to the end. Well, yes, in this case, yes. World. Or if we're at to beginning of existing gesture ID. Oh, and I guess here we should write gesture canvas mode for all of them. In this case, we do exactly the same, but instead, this one parameter here is different, it's false. It's not false, it's false. Because this parameter is add to end, right? No, we want to add it to the beginning. Okay, so now the canvas should roughly do its thing. Now we can simplify this here by adding to our plan manager an interface for moving a control point. Yeah. What editor is this? This is Visual Studio Code. It's a JavaScript HTML based editor, so there's actually a tiny browser running in this window. Written by Microsoft, it's very similar to Atom in this sense, but it's implemented much more efficiently somehow. There's lots of plugins, like you can see the Rust plugin works pretty well with autocomplete. And it's basically my favorite editor. I really like it. Okay, move control point. What do we need again? A proposal ID, view size, gesture ID, gesture ID. We want a point index, like which of the points do we actually move, and yeah, delta, by how much do we move it, which is a two-dimensional vector, so vector 2. I will need to import that. I don't care about this. I will need to import that. Here in each case we need to do self clear previous. let's import it to the dimensional vector. All right, Jesse, thanks so much. I will definitely check it out. I really appreciate your, once again, probably quite detailed work. Looking forward to that. And have a good night. And see you around sometime. Take care. So, move control point. And we can take the logic which we like. Oh, and we have these two cases of delta and is it ongoing. Let me just take everything from here. Is smooth finished. Yeah, and that will actually make things simpler. Let's first copy this and do this properly. So we will again need the current gesture. Basically this whole thing. So I guess let's actually abstract that away. Self gesture ID in a specific, like assuming a specific proposal ID. And then we do this stuff here. And we add our to-do comment here that there should be a more efficient way. And then we just reuse that code down there. Becomes a bit cleaner because we'll need the same again here when we move a control point, right? Because then here just get the logic proper here. If the move is finished, we start a new step, and in any case, we clear the previous. This is just point index. Here we have our delta, by how much we want to move the point. This returns a gesture. Right? No, this returns a Reference to gesture, etc. Probably will we get lifetime issues here? No. Oh, that's interesting. Okay, we moved. We now have the move control point directly on the plan manager as well, which allows us also for this operation to have a nice interface here, which will make our interactable code much simpler. I will get to that in a moment. I need to open the window again and take a small break. In the meantime, like before, write any questions that you have about the code so far, or about anything whatsoever. And okay, I think I will actually kind of officially take a small break. So let me switch to here, taking a break. And hey, I could actually try something. I could add a window capture here of just the live chat, right? And then have the live chat here even on the break screen. I mean, people will have it on the VOD, but so you can see where you're at. Cool. Okay. I will be right back. Let's say around 5 minutes, okay? And we're back. Let me know if you can hear me and if you can see me. How are you guys doing? I'm still feeling quite well, even though we've been going on for almost 3 hours now. I think I should be able to do at least another hour of coding, if not more, before I need a longer break. I'll just maybe if you also took a break, just well, then you won't hear this now, but just let me know if you're back and ready, everyone, okay? Sorry for scaring you. What do you guys think about some music? Should I add some to the stream, or are you good like this? Alright, since I scared everyone by saying that I'm back, should I get some jingle or something? How can we avoid this? Just like start talking as I approach from the distance. Anyways, I think we're good to ready to continue. So what did we achieve by moving all the interfaces here? We significantly simplified the gesture canvas. As you can see, it basically only directly converts the drags into these commands for our plan manager. But what about our gesture interactable? I will explain in a second how we will be able to drastically simplify that now thanks to this move control point thing here. All right. What do you mean by snapping? Oh, I see. Yeah, that should definitely also be handled by gestures, like making stuff parallel, making stuff snap to each other's ends, or like 45-degree angles, what have you. That's exactly part of the gestures interface, and but I will add it later. But it should fit much more naturally here than into my old implementation, which is a good sign. Okay, so the cool thing is, like, remember our gesture interactable had to remember its own gesture, including all points, to be able to like find the closest control point, then somehow create a new gesture that represents the old gesture plus the moved point. We don't need any of that now, which is in fact why I will comment this out and replace it by something much simpler. Because now what we can do is just have an interactable for every single control point, which is much leaner. Control point interactable. Well, it has its own ID. But then it just needs to know which plan manager it should report to, basically, which proposal ID it's from, and which gesture ID it's from. Interestingly, it doesn't even need to know where it is exactly by itself. I need to explain for that how my UI system works. Basically, in the UI system, when you add a new interactable, you tell the UI system, here's an interactable which knows how to react to drags and mouse overs and all that kind of stuff. And I wanted to have an active shape of a certain geometrical shape. So you can imagine like here, I don't know, this button, if you look at my cursor, you can see kind of the area where it becomes active and where it starts receiving the mouse events as its own. It's the same in my system, only that it's embedded in the 3D world. So what we'll be able to do is just for every control point of every gesture, we add this control point interactable, and we just tell the user interface, look, it has this like circular button area around it where it is actually interactive and where it uniquely responds to interaction events. And then it itself doesn't even need to know where it is or how big it is. Just whichever drag events it gets because they start inside of it, it will take care of. Does that make sense? I think that will make more sense later when it actually starts working. So let's implement that. And that code now becomes a lot simpler. We will only need this radius later now, when we actually add these interactables. So implement interactable 3D for control point interactable. And we only care about drag ongoing and drag finished, so we can copy this. So if we have some from to is finished, if we have that, then what do we do? Well, delta is 2 minus from into 2D, so the drag distance basically, and then we just say, well, self plan manager, let me save that. Oh, I need to have defined the function, of course. Okay, so if self plan manager, not if, just self plan manager move control point, and then what did we have? Proposal gesture point index. Oh, it needs to know which point within the gesture it is, of course, which is just an unsigned integer. So takes the proposal ID, gesture ID, point index, and our delta, and that's it. And that's all it needs to do. That's simple. Interestingly, which one is missing? Is move finished, yeah. Interestingly, these interactables won't even need to draw themselves as circles. We basically just make the whole plan manager renderable, and that just draws circles in all the places where control points are. That's true. It just draws circuits in all the places where control points are, and then there just happen to be invisible interactables at the same point. So you can kind of see how even the rendering of the UI is decoupled. And like you kind of, because of that, easily things like the control points are represented as small circles visually, but the clickable area is actually larger and stuff like this. So now we have this really easy, simple control points. And we will still keep this constant around here for later. So now So now we have basically everything we need. We have our gesture canvas for adding points, either to start a new gesture or to extend an existing one. And we have our control point interactables for moving control points around. Now, we need to actually implement for a specific user, when they switch to a proposal, they want to edit it now, that the correct interactables are created, and that when they move stuff around, that or create stuff, that new interactables are added as they go, right? Yeah, let's implement the logic for that. So in the UI state for each player, which is represented by this machine ID here, what do we need? We already have the current proposal. Okay, current preview is not that important yet. We'll do that in the next step. We need to have our basically current interactables, which is actually a vector of okay, no, let's split it up. Current canvas, or actually just canvas, and we might not have it yet, so we'll make it an option. Gesture canvas ID, and our control point interactables, which is a vector of control point interactable IDs. Okay. So, okay, now we need to add constructors and basically destructors to our interactables, because we create them initially, and they need to get hooked up to the correct plan manager. They need to be told their proposal ID, gesture ID, and so on. And in the end, when we change something about the plan, they are obsolete, and we need to destroy them and create new ones, right? So let's implement that. Control point interactable. The convention that I use, because this is an actor, is that I call it spawn, takes its ID, which it will actually get from the system, plan manager, proposal ID, gesture ID, and the point index. World, returns a new control point interactable, and that's actually also here for the initializer. I give it the user interface which we want to add it to. We will need to import that, and then you will understand what I talked about earlier. User interface ID, we have that. Okay, so first and foremost, we just actually return the interactable with the ID, with the plan manager, with the proposal ID. Can just, because it's the same names, I don't need to put their colons. The gesture ID with the point index. This is what we want to return in the end. But we also want to inform the user interface that we're actually adding a new interactable, so we use the add function. Now we need to say to which user interface layer we added. These are basically user interface modes that we can be in. For example, we could be in the road drawing mode and the building inspection modes. So there's a separate file for that. And we will actually go there and define, because I said earlier that we want to have both the old and the new road laying system at the same time, so we can interact with both and compare both. So we add a completely new UI mode that will allow us to play around with the first version of our gesture interface, okay? Okay. 3, 4. Okay. So we add our interactables to the new road layer for now. Or let's actually call it the gesture layer. Okay. So we will have the road mode, which is the old road interface, and we will have the new gesture mode where we draw gestures. Where was I? Here we added to the gesture layer. The ID of our interactable is our control point ID. And now our control point is an interactable, so its ID can be converted into an interactable ID. Now for the shape. And this is where we actually define the clickable area. So we import any shape from, I thought there, no, that was from, no, okay, any shape, and from here, from our geometry library, we import circle. I just had this weird moment where I completely forgot that I'm doing a live stream and just felt like I'm sitting at home alone talking to myself, which strictly I am, but all of you guys are watching. Hey there. And that's kind of cool. I guess it's a sign of extreme focus, which is cool. So, yeah, now we define the shape of our interactable. So any shape we want a circle, and in there we actually create a circle. Does it have a, yeah, I guess it's just a center. Oh, and here we don't just need the point index, but also the position. Here we need it, the interactable itself won't ever care about it. It's a two-dimensional point. But for the user interface, yeah, for the user interface we need to define it. So the center is at position. The radius is exactly our control point handle radius. Okay, so we defined the shape of our interactable. What's next? Z-index is basically defining which element gets precedence, like if they're on top of each other, which is more clickable, but I will just put them all into the 0 Z layer for now. Yeah, that's fine. World, and this, hope, once the code is correct, it should format this into something nicer than the super long line here. Oh, okay. Boom, formatted it. So this is how we spawn a control point interactable. So let's also add a message for when it becomes obsolete. We want to remove it again. And for that we just need to pass it the user interface so it can properly deregister itself. And this message handler will return a fate, because our actor will actually die. So returns a fade. So what it does is user interface remove from the gesture layer our interactable, and then kindly die. Good. Just forgot some stuff there. This is what it should look like. Okay, we need to do the same for the canvas, even though we need to, yeah, we only need to recreate that one much more rarely, because we only ever need a new canvas when we switch between proposals, right? How many people are still watching, by the way? I wonder. 31. That's pretty damn cool, actually. People stick around for quite long. Or some problems with the bitrate. Let me know if you experienced any glitches throughout. But I assume that if it was too bad, you would have told me already. Okay, we do the same for the canvas. Implement the gesture canvas. Define the spawn function. We need the user interface also here. Proposal ID. And that's it. So we return in the end canvas. So gesture canvas ID plan. Oh, we need the plan manager. Thanks for letting me know. Plan manager, proposal ID, then current mode, like the default initial mode is just, of course, start a new gesture. Oh, we didn't define yet. Yeah, but we'll notice that when testing. That's an oversight. We didn't really think about how we finish drawing a gesture. My most intuitive or most expectable idea would be to double click on the most recently drawn point. We will need to add the logic for that in the gesture canvas so that it then flips back to its default mode again. Right? And here we need to register our canvas with the user interface. Where, okay, you will understand the z-index in a second. So user interface, we add an interactable to the gesture layer. Probably I should call them UI modes. Let's actually go ahead and do that. Because layer is kind of... Well, okay, whatever. Why I stream at 60 FPS? Is it really that needed? Programming is not that action-packed. Yeah, I mean, I just really like that all the interactions look more fluid. It's easier for your brain, and when we do run the game, it looks much nicer. I don't actually know if on YouTube it's possible for you, if your internet connection can't handle it, if you can not only choose a different resolution, but if you can go down to 30 FPS. I don't know if it re-encodes for that. That would be interesting to know. I think I can see here now what I can see what people scream at. Is that right? It just says 1080p, not which frame rate. Oh well. So again, we add our gesture canvas to the user interface. So again, ID, we convert it into a generic interactable ID. Where is the gesture canvas? Well, it's everywhere. Now we use the z-index. So let's actually say that the canvas is the bottommost interactable element, and then we make the control point interactables to be above that, because it's basically about resolving conflicts. If you click somewhere where a control point interactable is, well, below that there's also the canvas, because the canvas is everywhere, right? So who should get the click event? Well, we want the control point interactable to get the click event. So by giving it a z-index of 1, this is kind of like parallel logic to how web UIs work. There it's also called z-index. So we kind of imagine that the control point interactable floats above the canvas, so if we click it, this is the preferred interactable to get mouse focus. Canvas is below at 0, okay? Then we can actually just copy the remove function here. And yeah, we don't, just 0. Once we fix all mistakes, where's the... Once we fix all mistakes. Okay, I feel like that's a good compromise. If there's anyone who wants to watch in 1080 or 720p, but 60 frames is too much and that's annoying, let me know, and then I will reconsider how I do that. But for now, I'll leave it like that. Why does it... oops. No, that's not what I wanted to do. Probably can't cancel now, whatever. There's a bug somewhere. I don't know why it doesn't reform it. Did it reform it now? Yeah, okay, perfect. So I accidentally started a build, so we need to give it some time to finish that. But okay, we can actually continue implementing the plan manager. So so we have two things. We have recreate control point interactables. This is something which we need to be able to do. Shit, now the laptop is getting hot during the streaming and the compiling at the same time. Interesting if it can keep up. That looks like it. And now we actually get this issue. We will fix that later. Why did we never get this before? Okay, so now we're getting actually lifetime bugs, but we'll take care of that in a second. We'll first sketch down all the important parts of the code so we have it captured. So when we recreate the control point interactables, because we moved one, for example, or we added a new one, what do we need to do? We actually only want to do that for a specific proposal. So for state yeah, actually even the clearing of previews we only want to do for a specific proposal ID, right? So only these where state current proposal equals some proposal ID. Then we do the same here. So for control point interactable in state control point interactables, and then I used drain, which both iterates over the control point interactables, which we remembered here, as well as empty stem. What do? We call remove with our state user interface to kill it. Should do the trick. No. So for the UI state for each, okay, just should be called user interface. So we have we can send messages to the user interface of each multiplayer player. And alright, cool, that works. So now we need to think. If we start a new gesture, we need to clear the preview of that proposal ID. And we also need to recreate control point interactables that proposal ID. It's maybe a bit inefficient to recreate all the control point interactables after every single step. But let's do that for now, then optimize that later if it turns out to be a problem. Same if we add a control point, we update the preview of that proposal ID, and we recreate the control point interactables. If we move a control point, we definitely don't want to recreate the control point interactables until the drag is done. Because, yeah, while we're dragging, all the other control points are still fine, of course. So only if the move is finished do we do that. And even I'll add this as a note here. can we update only part of the preview for better rendering performance while dragging? That's something that we will try to figure out later, okay? Oh, we need to pass it the world. I feel quite productive. We've written a lot of code during this live stream. I mean, how long is this file now? Oh, already 400 lines. Starting to reach the point where it becomes time to split it up, but for now we'll just keep it all in one long file. Okay, so what is missing? Yeah, oh, we only remove the control point interactables, but we don't actually add the new ones. So, okay, so uptime, I guess that only works on Twitch. You mean for how long the stream has been going? I think we can see that here now. Wait, what does that mean? 11. Well, we started at 1:07 p.m. and now it's 4:30. So that's 3 hours 30, right? Okay, back to here. So to recreate the control points, we actually need to, yeah, almost nothing. We need to have a preview of the resulting plan, which means the master plan of the whole city together with the current proposal. So we want to just write a quick helper function to get that for a specific proposal ID. And that returns a reference to a plan. So if some preview equals self for a specific machine ID, if we have a preview, then we return the preview. Or yeah, I mean, as reference unwrap. unwrap is like expect but without an explanation, when it's even more obvious. So because here we will, if this is none, then set it to some self proposals proposal ID apply to self master plan. Okay. And then it's then we have it for sure. Expect ID for this machine. Like this. Okay, because then we can use that here. A preview self look at the intense shaky cam action during intense typing. Yeah, that's I guess that would be a lot nicer with the DSLR, which I already have standing there on a tripod, but the connection is too slow over Wi-Fi. So like I said, I'll try to get a USB cable to use that as my webcam, which will result hopefully in a higher quality picture of myself and less shaking during intense typing. Initial preview for this proposal ID. And then for gesture in preview gestures values, or actually pairs for gesture ID, gesture in this. Okay. We want to create a control point interactable. So control point interactable ID spawn state user interface proposal ID gesture ID. Oh yeah, and then for point index point in gesture points iterate enumerate. So where were we? Point index position is point alt. Okay. So this should, for all points in all gestures, spawn a control point interactable. And oh, this will actually return the ID of the newly spawned interactable. So Sorry, we need to do a small step in between here. None. So just making this iteration here a bit clearer. For machine ID in this, let status self UI state at this get not mutable machine ID unwrap that exists for sure. Having a short brain fog. Try to. What did I actually want to do? Okay, because now we know the machine ID, right? Can do ensure preview. For this machine ID, okay. That seems a little complicated to do like this, but whatever, we can clean it up later. So we have the preview, and then we can actually iterate through all the gestures of the preview. What does it complain? Okay, and then so that's a reference and we want a value because the machine ID is just a number, we can just reference it. It's basically trivially copyable. And then we don't just want to iterate over that, but actually use that to collect our new control point interactable. So state control point interactables is actually these map something something collect, and then we map. Basically, we convert this iteration into a mapping, and it will be a flat map because for each gesture there will be many control point interactables. So gesture iterate enumerate map this into this spawn statement, which returns the ID of our new interactable, and then we collect them again like this. Let me know how you guys are doing, if you're still following along. This was a little bit of just pushing code around. What is it about? Expected 7 parameters. What's missing? Oh, it needs the plan manager. So that's just self ID, right? Oh no, that should even be... Oh, that's correct. This is a reference, but again, gesture IDs are trivially copyable. Same for two-dimensional points. So we convert them from references into values like this. No? Expected a point, found reference. I guess this is a double reference. No? Okay, now something weird is going on. So, like this, what does it complain? Expected a point, found reference. Dimensions work out. So we dereference it once and then. Oh, that was just a glitch over there. Okay, never mind. So it's not called preview. How is it called then? Current preview. Okay. Okay, this is probably some borrowing and lifetime shit we need to figure out later. Maybe even understands that. And now we're getting borrowing and mutability problems, which we will sort out eventually. So at which point do we really need to recreate the canvas? Only when a user changes which proposal to look at, right? Yeah, so we create control point interactables. So we had a public function switch to, or I guess yeah, let's not deal with that now. Not yet, at least. Okay, I want to get close to a point where we can actually get this running. I'm starting to feel a bit tired. So, and also hungry. So I would suggest that I take a longer break, maybe 1 or 2 hours, and then we continue with programming. Now the question is, would you be interested in a patrons calling style call right now? To just talk about pretty much whatever about Citybound? Is there someone who would like to call in live and have a live discussion with me? Or do we already take a break now? Let me know what you would prefer. You want to know more? Whoops. You want to know a bit more about the actor model. Okay. Do you have a microphone, and would you be able to ask me these questions live by calling in? Because then I'm happy to answer whatever technical questions you might have about that. I think with chat it's going to be a bit difficult with the delay. So everyone who would be happy to call in live, please let me know in the chat. All you need is a microphone. And if there's, let's say if there's 2 people, let's do it now. Yeah, thank you for the feedback. Especially the last part is like a lot of moving code around, not really that closely related to the conceptual work anymore. Okay, cool, fair enough. So what I think I will actually do is I will take a longer break of maybe 3 hours and try to get some of the annoying, just like pushing code around work out of the way, so that we have a little more juicier part later where hopefully we can actually see the UI working. Okay, since there doesn't seem to be too much interest into a call right now, I will finish the stream here, and let's aim for, I don't know what time zone you all guys are based in, but let's aim for maybe in 3 hours, so that would be 8 my time for another coding live stream, and then maybe later at night for me a patrons calling if there's more interest. Then I will announce the exact date when we start again on the subreddit and on Twitter, as well as the like unified blog post about the hackathon. So stay tuned for that. Thank you all very much for watching this first live stream of the hackathon. I hope you enjoyed it. The next ones will definitely get more interactive and more visual with regards of what we're programming. If you have any wishes for the streams, any ideas, any feedback about how this one was, go to the Reddit thread about the blog post of the live stream, which is just called the March 18 Hackathon, and post it there. I think it's good if we use that as like kind of a central place to discuss the live streams. So yeah, take care and see you later today. Some of you hopefully, and maybe some new people. Bye bye.